Hi everyone. Let's dive straight into today's problem. We are tasked with finding all integer pairs x and y that satisfy the equation x squared plus 1, y squared plus 1 equals 2 times xy minus 1 times x plus y. Let's get started. The first thing we notice about this equation is that it's symmetric in x and y. That is, if x and y is a solution, then swapping x and y is also a solution. This is a key property that will help us along the way. Let's now try some specific values for x. Starting with x equals 0. Substituting this into the equation gives 0 squared plus 1, y squared plus 1 equals 2 times 0 times y minus 1 times 0 plus y, which simplifies to 1. Y squared plus 1 equals 2 times negative 1 times y, and we can rewrite it as y squared plus 2, y plus 1 equals 0, which simplifies further to y plus 1 squared equals 0. Therefore, y equals negative 1. So, one solution is x equals 0, y equals negative 1. Now, using the symmetry property we discussed earlier, if x equals 0 and y equals negative 1 is a solution, then swapping x and y gives us another solution x equals negative 1 and y equals 0. So far, we've found two solutions x equals 0, y equals negative 1, and x equals negative 1, y equals 0. Let's now proceed with exploring other possibilities. Next, let's expand the left-hand side of the equation. X squared plus 1, y squared plus 1 equals x squared y squared plus x squared plus y squared plus 1. This simplifies to xy minus 1 squared plus x plus y squared dot. Now, applying the arithmetic mean-geometric mean inequality, we know that for any non-negative numbers, we have xy minus 1 squared plus x plus y squared is greater than or equal to 2 times xy minus 1 times x plus y. Since the equation is an equality, this confirms that there's a close relationship between x and y, which will help us further in solving this equation. Now, from the expanded form, we have xy minus 1 squared equals x plus y squared. This implies xy minus 1 equals x plus y. Rearranging the equation gives xy minus x minus y equals 1, or x minus 1, y minus 1 equals 2. Now we solve this by considering the integer factorizations of 2. The integer factorizations of 2 are x minus 1, y minus 1 equals 1, 2, 2, 1, minus 1 minus 2, minus 2, minus 1. Solving for x and y in each case gives the solutions x, y equals 2, 3, 3, 2, 0, minus 1, minus 1, 0. Since we already found x equals 0, y equals negative 1 and x equals negative 1, y equals 0 earlier, we now have two additional solutions x equals 2, y equals 3 and x equals 3, y equals 2. Thank you for watching. If you enjoyed this problem, don't forget to like the video and subscribe for more challenging math problems.